Today's lesson is called Solving Compound Statements. So let's look at our first example. Consider the compound inequality x plus 4 is less than 6 or x minus 1 is greater than 3. You're going to notice that our previous lesson on compound statements is now going to be added into solving. So we're going to be using the skills from the previous lesson with solving inequalities to answer questions. So we're going to solve each equality for x, then write a sentence describing the possible values of x. So when it's an or like this, we have two inequalities that we're going to solve. So I'm going to start with x plus 4 is less than or equal to 6. In order to get x alone, I would have to subtract 4 from both sides. This becomes x, the 4's are gone, is less than or equal to 6 take away 4 would be 2. So I have x is less than or equal to 2. Then we have the other inequality, x minus 1 is greater than 3. So I would add 1 to both sides of the inequality to get x is greater than 4. Now remember, this was an or statement. So in the middle here, we would have or, one or the other. So the way I would write this in words is x is less than or equal to two, or we have greater than 4. So now this is where the graphing from our previous lesson is going to come into play. Now remember, this is an or. So this is not where we're going to have overlapping graphing and the things are sandwiched in between. This is you're in one place or you're in the other. So x is less than or equal to 2 means I'm going to have a filled in circle at 2, and I'm going to shade where it's less than that. Okay. Then we also have or x is greater than 4. So here the circle would be open because 4 is not included, and I'd be shading to the right. So notice, this is not one where it's in between. I'm either in one place or I'm in the other. Now in example 2, we're going to consider the compound inequality negative 15 is less than negative 3x minus 21 is less than 5. Now before I even do anything with this, you're going to notice that this time the x in the expression is already sandwiched in between negative 15 and 5. So right away, this should be an indication to us that when we go to do our number line, this is going to be the type of situation that leads us to shading in between two values. So in A, first we want to rewrite the inequality as a compound statement of inequality, and then we are going to solve the inequality for x and write the solution to this inequality. Now, I'm actually going to show you how to do this two different ways. We're going to address the way that it's worded first. So when you have a compound inequality like this, you're going to look at it like it's two problems linked with the word and this time instead of or because of the way it's originally written. Because the expression's in the middle, you have to be greater than negative 15, but also less than 5 at the same time. So you almost think of it like this. Do not do this, but I want to show you. You're going to think about this as if that's not even there, and that's one of our inequalities. Then you're going to think about it like this isn't even here, and that's one of your inequalities. Okay, so I kind of want you to know that before we even start writing it, that that's how we're going to look at it. So first, we're going to write down negative 15 is less than negative 3x minus 21. But at the same time, so and, we have the other side of the inequality, which would be negative 3x minus 21 is less than 5. I'm going to put a line here because we're going to solve these on one side, and then I'll show you the other way you can actually solve these on the right-hand side. So solving this one first, I'm going to add 21 to both sides because I'm trying to get x alone. This is going to give me 6 is less than negative 3x because the 21s are now gone. So now I'm going to divide by negative 3. I'm dividing by a negative. Make sure this symbol flips. okay? So you're going to have x, the symbol's going to flip the inequality symbol the opposite way, and you're going to have -2. Now, I know a lot of you do not like looking at it like this, me included. So if you want to write it with variable first, that'd be fine, x, and you have -2. Just make sure the mouth is still open towards the correct number. So this would be the same as this. Okay? Then on the other side, we're going to add 21. We get -3x, the 21 is gone, is less than 26. We're going to divide by -3 on each side. So again, we have this issue with the symbol. X is going to now be greater than negative, and we can either leave this as 26/3 or we can make it a mixed number as -8 2/3, which might be easier for you to think of when graphing. So if I look at these two things, both of them have to happen at the same time. And we know it's going to be one where it's sandwiched in between. So we're going to have our x values. It's going to look like this because they're symbols with no or equal to. And you want to put the lower number first. So the -8 2/3 is going to go on this side. This is the lower bound. And then the -2 is going to go on that side because that would be the upper bound, the highest. And our x value is going to be sandwiched in between. Now, I also like to do it this way where we leave it as a compound inequality the way it's written as right now, not splitting it up. So I'm going to rewrite our original problem exactly as it looked. And I just want you to work in all three sections at the same time so that we keep the value of the inequality. So I'm still going to just work in the middle. Okay, so I'm going to highlight that section for you. The way we do it if we leave it like this is we look at the middle and work off of the middle. We know we need to get x alone, so we have to get rid of 21. So I'm going to add 21, but I just have to do it now in 3 places. So that's going to give me 6 is less than. I'm going to get -3x, the 21s are gone, and less than 26. So again, I'm still working in the part where the variable is. So I'm working in the middle. So I'm going to divide everything by -3. It's just that I'm going to do it again in all 3 sections. So I'm going to get -2. Now I'm dividing by a negative, so my symbol has to flip. The -3 is gone, and I get x. Again, the symbol flipped. And here's my -8 2/3. Now at first it's looking like it's backwards, but it's not. If you look at the ones over here, it's less thans. This side now is greater thans. So as soon as we switch this around, -8 2/3, mouth still open towards the same thing would make it less than x, which would make it less than -2. So you can do it either way. Either way, though, this is our solution, and you can see the difference in example 2 from example 1 when the word and is used and it's sandwiched in between. So when we write a sentence that describes the possible values of x, we're going to this time say x is between. I'm going to underline that because it's important. -8 2/3. And another important word, -2. Okay, but we're going to talk about whether their values are included or not, just like we did in example 1. So we're going to say not including -8 2/3 and -2 to show that those should be not included values. So this time when we graph it, this is sandwiched in between 2 numbers. So -8 2/3 is going to be about 2/3 of the way towards -9, about here, and that's going to be an open circle, not included. -2 is also not included, so an open circle, and this time we're shading in between. So what I'd like to do on the next page is show you an example of a word problem where solving something like this would come into play. So example 3 says the antifreeze added to your car's cooling system claims that it will protect your car to -3 degrees Celsius and 120 degrees Celsius. The coolant will remain in a liquid state as long as the temperature in Celsius satisfies the inequality -35 is less than C is less than 120. We want to write this inequality in degrees Fahrenheit. So first, let me give you the formula for changing this. We're going to have C equals 5/9 times the Fahrenheit temperature minus 32. So our inequality used to have a C in the middle, but now I'm telling you C is equal to this formula. So we're going to replace the C with 5/9 times the quantity F minus 32. So we're going to have negative 35 is less than 5/9 times F minus 32, which is less than 120. So again, you can split this up if you would like, or you can work right within the 3 setup. I'm going to show you splitting it up. So we have negative 35 is less than 5/9 times F minus 32, which means we're going to have to distribute. So we get negative 35 is less than 5/9 F. And this time you would get 160 over 9. I'm just leave it like that for you. Now we're trying to get F alone. So we want to add 160 over 9 to both sides. And we would get negative 155 over 9 is less than 5/9 F. Now at this point, we'd have to multiply by our reciprocal to get rid of 5/9. So that would be 9/5 on this side and also 9/5 on this side. So when we do that, these 5/9 cancel out and we have F is greater than, when you actually do this math, you end up with negative 31. This is happening at the same time, so we're going to use and because it's sandwiched in between. The other inequality, which would be 5/9 times F minus 32, is less than 120. So we're going to start the same way with our distributive property, getting 5/9 F. We already have the value from the other side, 160 over 9 is less than 120. We're going to do the same step of adding 160 over 9 to both sides, and we get 5/9 F is less than, when you add those two numbers, you get 1,240 over 9. Again, we're going to have to multiply by the reciprocal in order to get F alone, which is going to cancel these out, and we get F is less than, when you figure this one out, you're going to get 248. So now we know our final answer is we've got to go from negative 31 degrees, it's Fahrenheit now, up to 248 degrees. We have converted it into Fahrenheit. Now, lastly, underneath, this is for reference, and you can do this now on your own time with a graphing calculator. You can test out how this can show you the way to do it on a graphing calculator. Okay, so we already know how to do it algebraically. You would solve each equation separately, and the answer will be points that make both sets true. Graphically, if you follow the directions that are there, it will make the number line for you, just ignoring the y-axis and using only the x-axis. So you can stop the video now, the lesson is complete, and you can try that out on your own with your graphing calculator. And this concludes our lesson on solving compound statements.